Okay, this extremely fun topic goes by the name algebra solving. Very important to learn it early in your math career so that coming to maths doesn't stress you out. Not that it stresses many of you out, probably. Okay, very, very simple problem, but I'll just explain the idea of an equal sign tells me that the equation is exactly in balance. In other words, think of a seesaw or a set of scales in science, and the weight on the left is exactly in balance with the weight on the right. That's what the equals sign does for me in an equation. And as you know, to keep a set of scales in balance, if you add weight to the right, say plus 2 kgs, you should also add weight to the left, say plus 2 kgs. So whatever you do to one side of the scales, you better do to the other to keep it in balance. Or let's say I wanted to minus 10 kg, I would also minus 10 kg to keep it in balance. How about doubling the weight? Well, I better double the weight on the left hand side, otherwise it's not going to keep in balance. How about dividing the weight by 3 on the right? You better also divide the left hand side by 3. Better stay in balance. The moment it goes out of balance, you've made a mistake. I could even take the square root of the right hand side. That would stay in balance if I took the square root of the left hand side. What are some other operations I could do to both sides? Yes? Factorize, did you say? Factorial. That's an interesting one. I think for the moment, Alex, we'll come back to that. But for the moment, we'll leave factorial. What are some other... What's the opposite to square root? If you powers. So if I say square, like a little 2, one side, I better square the other side, keep in balance. I could cube, little 3, both sides, but whatever I do to one side, I better keep it in balance by doing it to the other side. So in my first question on page 169, what I'm going to do is I want to, in my terms, make x the subject. Possibly in English, make x by itself. At the moment, 4 is being added to x. To undo a plus, we do a... How do you undo plus? Minus. So I'm going to subtract 4 from the left and subtract 4 from the right, because my seesaw or my balance is still in balance because I did the same thing to both sides. What the beauty of this though is when I subtract 4 from the left, it undoes the plus 4, and when I subtract 4 from 9, I wind up with 5. And you probably could all see that was the answer anyway, but the principle is the important part, because when the equations get very difficult, you need to understand it from first principles, or understand what I do to one side, I also must do to the other. If I jump down to question number 2a, it reads 2x plus 7 equals 11. Don't think of the X as a letter in the alphabet. Think of it as a number that I need to find out. It just stands for a unknown that we're going to find out. This unknown was multiplied by 2 and then 7 was added, and the result was 11. If it was first multiplied by 2 and then 7 was added, to undo, you have to undo in the reverse order that things were done. So the first step has to be minus 7, because the last thing that was done to x was 7 was added. So undoing, I should do the minus first. But don't forget to do it to both sides of the equation. Just keep it in balance. 2x plus 7 minus 7, the beauty of that is that 7's disappear, and on the left hand side I'm just left with 2x. On the right hand side I'm left with 11 minus 7, which is thank you, 4. This unknown x was multiplied by 2. In algebra you never ever see multiplication signs. We just push letters and numbers together and leave the multiplication sign out. But secretly you know that there's actually multiplication happening between the 2 and the x. To undo multiplication we use division. You may have seen this table before. This is the operation. If it's plus to undo, we use minus. If it's minus to undo it, we use plus. If it's multiplication to undo it, we use division. If it's division to undo it, we use multiplication. If it's squared to undo it, we use square root. If it's had the square root taken, to undo the square root we use if it's cubed, to undo the cube we use the cubed root. Not often talked about, but there is such thing as a cubed root. Interestingly enough, this is there is a silent 2 here because you're undoing the undoing the square, but because we're lazy we don't often write the 2 there. This is the undoing cubed root. Okay, leave that aside. 2 times something gives 4. Well, I'm going to do the same operation to both sides. I'm going to divide by 2 because that undoes multiplication. Great, when you multiply 2 and then divide it by 2, the 2's cancel. And I'm left with x on its own. What's 4 divided by 2? I can check my answer. If I put 2 in for x, I can go 2 times 2, that's 4, 4 plus 7, 4 plus, that's 11. So I know I've found the correct answer. Question number 3 reads x over 3 plus 2 equals 5. The x was divided by 3 first, then 2 was added. Not You don't add 2 and then divide by 3. That would give you a wrong answer. You divide by 3, then add 2. So to solve this problem, I have to undo the plus 2 first, not undo the division by 3. To undo plus 2, I have to subtract 2 from the left and subtract 2 from the right. On the left, I'm left with just the x over 3. On the right, I'm left with 3 because 5 minus 2 is 3. And the equation is still in balance. X was divided by 3. To undo division by 3, I multiply by 3. Multiply left by 3, multiply right by 3. That's brilliant for the left because it just leaves me with x. And 3 times 3 is 9. Again, just check your answer. Put 9 in for x. 9 divided by 3 is 3. Plus 2. That works. I'll do I for you at the same time. Here's 1i. Minus x over 5 equals 3. To get rid of the 5, I multiply by the denominator. That gets rid of the 5. I'm left with minus x equals, what's 3 times 5? In here, there's actually a minus 1 multiplied by x. Whoops. Multiplied by x. To undo multiplication, we use division. So we divide by minus 1 both sides. The minus 1's cancel. I'm left with x equals 15 divided by minus 1, which is minus 15. Check my answer. Minus 15 into there. Minus 15 is positive 15 divided by 5 is positive 3.